Hi, I'm Yousif and I'll be explaining Lab 2. For part 1, we were required to calculate the cyclic redundancy check or CRC using polynomial division. We used the data word polynomial created, created from specific digits in our student IDs and divided it by the given generator polynomial, which was 6 x power 6 plus x power 3 plus 1. This process helped us understand how error detection works at the data link layer, ensuring that data is transmitted accurately without corruption. For task 2, here we simulated stop and wait automatic repeat request protocol. Show you. Used in TFTP, we analyzed what happens when packets or acknowledgements are lost during transmission. I explained how the sender waits for acknowledgement, starts a timer, retransmits if a timeout occurs, and how both client and server manage frame numbers. This task demonstrated reliable communication through acknowledgement and retransmission. And as for the odd student ID number, the block 3 was lost and acknowledgement from block 4 was lost. Moving to part 2, in which we were required to install Wireshark, which is a packet sniffer. After installing our Wireshark and setting it up to capture and analyze local ICMP data. In this, we were required to run this command on our command prompt and see the details for our default gateway, IP address, and subnet mask. These are further details required in the lab, which was Windows IP configuration. We found all the IP addresses, subnet mask, and default gateways again. Step 2, we start Wireshark and begin capturing data, in which we were required to ping our teammates' IP address. In our case, we were facing an issue in the start because of firewall, and then we managed to make it work. And this was the result after I pinged my teammates' IP address. After this, we were required to run the command tracer to find the distance or time required for the ping to happen. This is a screenshot which was already given to us in the lab, which we were required to examine and give answers for the question. This is only for ICMP. And in part 3, we examine the header file fields in an Ethernet 2 frame, which we get from here. Ethernet 2 source, and then this is the frame we have to examine. After examining the frame, we were able to find all of these answers. And again, we were required to run the prompt with our student ID. So first 4 digits were the last 4 digits for the first student ID, and last 4 digits were the last 4 digits for the second student ID. After running the prompt, this was all the data we acquired, and this is the screenshot showing the same. In step 3, examine the Ethernet frames in a capture. This is basically the frame we are examining. There will be a difference in the frame for ARP and ICMP file, which we can see here. As you can see, the frame here is very different compared to this frame here because this is only ICMP, and here we are looking at ARP. Now, after analyzing the frame, we got all the answers for the questions, and this is the table we filled. And these are all the questions we answered. Part 4, use Wireshark to capture and analyze Ethernet frames. In this, we ping our default gateway, and we capture the packet on Wireshark with only ICMP traffic, and then we examine it as required. These are the details we got after pinging the default gateway and examining the ICMP file. These are basic questions we were required to answer. Moving on to step 7, capture packets for a remote host. In this, we basically ping Cisco and we started capturing the packets. We faced some issue in the start, but again, we were able to make it work. Usually in the uni Wi-Fi, you cannot ping or use Wireshark, so we got back home and we did it. In this, we pinged Cisco, we found the source and destination, we found the IP addresses, and we found, yeah, this is the screenshot for the ICMP file after pinging Cisco. Then after that, we examined the captured data and we were able to answer all of the questions. Moving on to part 5, capture and analyze remote ICMP data in Wireshark. Finally, I pinged remote websites like Yahoo, Cisco, and Google while capturing traffic in Wireshark. I observed that each site had a different IP address but shared the same MAC address which belonged to my router. This showed that Wireshark can only detect MAC addresses on local network, not on the internet, since routers rewrite the MAC address at every hop. After capturing data on the interface, we were able to find the IP address for Yahoo, MAC address, which if you notice is same for both Yahoo and Cisco because again, this is the MAC address for the router and not exactly for Yahoo or Cisco. And these are all the questions answered. Finally, we have all the PCAP files here for part 1, part 3. This is for ICMP, then this is for ERP, and for part 4. Thank you.